Hi everyone, welcome to Sayar Robin's channel. I'm Sayar Robin. Today I'm going to show you how to calculate calculus problem, which is relating to the normal line equations, also tangent line equations too. Well, the problem is from specimen paper 2020 CIE IGCSE or CAIE IGCSE. Okay, let's do it right now. Okay, the problems, here we go. Find the equation of the normal to the curve. Okay, blah 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 at this point where x is equal to 2. Okay, you already know the parent functions, which is a rational functions. Right, so you have to be careful about if you're going to differentiate that kind of functions, because some students are weak at handling in third form. So I just want you to be careful when you do it. Give your answer in the form ax plus by is equal to c. Finally, your answer must be in the form like that, where a, b, and c are integers. Okay, so you can check whether your answer is get integers or not. A, b, and c. Okay. Before we are going to directly calculate these problems, I'm going to explain you some things which is about normal line equations, right? Okay, this is a GeoGebra software, right? So you can search internet. Okay, first of all, we are going to draw a graph. Okay, this is an arbitrary graph, y is equal to x squared graph. What is tangent line equations? Right, so before we do tangent line equations, I'm going to draw a tangent, right? So that I can draw a tangent, so I have to plot a point at 1, 1. Here we go, 1, 1. This is a point. So I'm going to draw a tangent line at that point. Well, tangent here. Okay, at the tangent line of this graph. Okay, obviously this is a tangent line, right? Now I'm going to draw normal line again. So normal line is perpendicular to the tangent line. So we are now going to draw a perpendicular line at point A. Okay, so now we are gonna find the normal line equation. Okay, this is a sample, and I'm just explaining you not really a problem. Here we go. Okay, let's think about this idea first. This is tangent line. This one is normal line, right? Normal line and tangent lines are always perpendicular each other. Okay, so what we can do it, obviously gradient of tangent is multiplied by gradient of normal is going to give you -1. Okay, if you could find the gradient of the tangent, so you can easily write down the gradient of the normal. Okay, so that you can find the gradient of the tangents, it's easy. You just need to differentiate to the parent functions or the given functions. After that, you have to substitute at the point that you want to find tangent line. All right. Okay, so equation of the normal or equation of the tangent, whatever it is, how we have to do it. Okay, you have to know y minus y1 is equal to gradient m into x minus s1. This formula is the really important to be able to find the gradient of tangent or gradient of normal. Okay, if you're gonna find a gradient of tangent, you just need to substitute the value into this gradient. If you want to find the normal, so you just need the value of the normal, value of the gradient of normal into this one. Okay, y1 and x1 are given point. Sometimes you have to find yourself, right? So this y and x are only variables. You don't need to think about it. Okay, let's do it right now. Well, I'm gonna delete it. Okay, and then I'm gonna erase it, right? Oh, before, okay, let it be. So I'm gonna copy the given function y is equal to 2x minus 1 over square root of x squared plus 5, right? So this is rational function, so you better use the quotient rule. Some students may use the product rule. It's okay. It's up to you. So in this problem, I'm gonna use the quotient rule. Okay, quotient rule. What is quotient rule? d dx of u over v equal to, okay, v du over dx. Okay, you have to differentiate the numerator first, and then numerator, and then dv over dx over, and then v squared. Okay, it's divided by v squared. The equation should be strictly like this. All right, so dy over dx is equal to, okay, this is a divided line, and then v squared, so we can do this one first, right? So square root of x squared plus 5 is raised to the power 2, so that's gonna be x squared plus 5, obviously, right? And then so we are gonna leave the denominator, so square root of a squared plus 5, and then differentiate the numerator, 2x minus 1, derivative of 2x minus 1. So you can write like this, right? d dx of 2x minus 1. You can leave this step so you can directly write down the answer. It's okay. Okay, negative and then minus, and then so now 2x minus 1 have to be leave, and then so never forget to write the parentheses, otherwise so you might something wrong, so want to continue the next steps. So this one is d dx of square root of x squared plus 5. I'm going to change the form x squared plus 5 to the power half. Okay, so we better write half because it is easy to understand when you do the differentiation in next step, right? Square root of x squared plus 5, and the derivative of 2x minus 1 is going to be 2 only. The derivative of 2x is equal to 2. Derivative of constant is 0. 2 plus 0 is gonna be 2. So we can write down 2 times square root of a squared plus 5. Okay, and the minus, and then we are now going to take down the power half. That's why I'm going to write here, and then 2x minus 1 decreased by 1. Therefore, a squared plus 5 to the power half minus 1 is negative half. And then we have to do the differentiation to the inside function again, right? Because this is chain rule. Okay, two functions are, one function is inside another function, right? Therefore, the a squared plus 5 is inside function. So we have to do the differentiation again. The derivative of a squared is going to be 2x. And then plus 0, okay, derivative of constant 5 is equal to 0, okay? We just need to write down 2, and then we can delete this 2 and this 2 because all of the things are multiplying each other. And then x squared plus 5. Now we are going to simplify, or you might leave in the steps because we are now calculating show the problem to get the answer they want. Okay, we just need to know the value. That's why, so you can directly substitute 2 into the given functions of the given derivative functions, right? So I'm going to try to get like this, right? dy over dx at x is equal to 2 equal to, so I'm going to skip this step, so because I'm going to substitute 2 into x. Keep in your mind 2 squared is equal to 4, 4 plus 5 is equal to 9. Square root of 9 is 3. 3 multiplied minus 2 is 6, right? Minus, how about this one? So we are now going to substitute, and then 2, and then this one is also 2, right? And then this one is also 2. Okay, let's do it in your mind. 2 times 4, 4 minus 1 is 3, okay? Multiply, and then 2 squared is equal to 4, 4 plus 5 is equal to 9, 9 to the power negative half, 9 to the power negative half, multiply by, okay, this one is only 2. 9 to the power negative half, how you understand it? It's easy. 9 to the power negative half means 1 over 9 to the power half. 1 over 9 to the power half means 1 over square root of 9. So we will get 1 over 3. This one is 1 over the, this one is 3. When you multiply these two things, it's going to be 1. 1 multiplied by 2 is 2. Therefore, I'm going to write down here 2. Okay? Over x squared plus 5. Now we are going to substitute 2 into x, right? 2 squared is 4. 4 plus 5 is 9, right? Equal to 6 minus 2 is 4 over 9. Okay, this is a derivative function, right? The value of derivative, sorry. Okay, the value of derivative. So if you're going to use this gradient value, so that can easily define the tangent equations. Okay, so I'm gonna erase this part. All right. Okay, so we are now going to find the point. We already know the x coordinate, so we just need to find the y coordinate only. X is equal to 2 implies y is equal to. We are now going to substitute into the given function here, x, right? So x is equal to 2. 2 times 4, 4 minus 1. Over square root of 2 square is 4, 4 plus 5. It's going to be 3 over 3 is 1, right? Therefore, the point is going to be 2, 1. Now you already know the gradient and the point you want, so you can easily write down the normal equation. Therefore, normal equation is y minus y1. Y is going to be 1 equal to gradient. Now we're going to substitute gradient. Okay, be careful. Because we have only the gradient of the tangent, so we are going to do the negative reciprocal to the gradient to be able to get the gradient of the tangent. Negative reciprocal. Therefore, negative reciprocal means 4 over 9 is going to be 9 over 4. Okay, just need to switch off. And then x minus x1 is going to be this one, right? This is y1. 2. All right. So now we are going to substitute throughout, we're going to multiply throughout by 4. So that becomes 4y minus 4 is equal to negative 9 times x minus 2. And then 4y minus 4 is equal to negative 9x plus 18. Okay. And now we are going to try to get given form, right? This form. Okay. Therefore, 4y minus 9 is going to be 4y plus 9x, and then equal to 18 plus 4 is 22. Okay, 9a is going to be first plus 4y is equal to 22. A is equal to 9, B is equal to 4, and C is equal to 22. Okay, that's all. Okay, enjoy it. See you again in the next problems.